We were talking about transformations of quadratic functions in Vertex form, and we want to be able to describe transformations in quadratic functions and write transformations of quadratic functions. So here we want to examine just the scale factor, or we're really going to look at the a-value. So we're going to examine how an a-value of 1, an a-value of 2, and an a-value of 1/2, how they are a little bit different. So here we have the parent function, x and y, and we're just going to look at 3 points for each. So x value of 0, 1, and 2. So we could work on the negative side, or negative values of -1 and -2 in that, but we're just going to look at the right side of the parabola. So if I substitute in 0 for this function here, 0 squared, 0 squared is equal to 0, 1 squared is equal to 1, and 2 squared is equal to 4. So we can graph that parent function. We have those points there. So we have the point 0, 0, we have the point 1, 1, and we have the point 2, 4. 1, 2, 1, 2, 3, 4. And that we can continue on in that as well. Next one we're going to look at is we're going to look at g of x here. And this g of x we're going to use red. And we're going to use the same points, 0, 1, and 2. So we'll substitute those values in. 2 times 0 squared. 0 squared is 0 times 2, that's still 0. 2 times 1 squared. 1 squared is 1 times 2 is 2. And then we have 2 times 2 squared. 2 squared is 4 times 2 is 8. So we can look at the points 0, 1, 4 and 0, 2, 8. If we notice, 2 is 2 times bigger than 1, and 8 is 2 times bigger than 4. So what this red graph here, g of x, is going to do is it's going to get really quick. It's going to get narrow and vertical quicker than the parent function did. So 0, 0 is a point we already have graphed. 1, 2, so we're going to go over 1. Instead of going up just 1, now we're going to go up 2, 1, 2. So now our g of x, or red function, is going to be 2 times higher than the parent function. And then 2, 8, so over 2, 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So now we can see a little bit more clearly that the g of x, or the red function, is getting more narrow quickly, twice as fast. 1, 2, 3, 4, 1, 2, 3, 4. So it's twice as high. And then the last one we can work with is h of x here. We're going to do the same thing that we did with the 3.0, 1, and 2. And we will do 1/2 times 0 squared. 0 squared is 0 times 1/2. That is still equal to 0. 1/2 times 1 squared. 1 squared is 1 times 1/2. That is 1/2. Oh, I already have the equal sign down there. And 1/2 times 2 squared. 2 squared is 4 times 1/2. That is equal to 2. So 0, 0 is already graphed. Now we have the point 1, 1/2. So we go over 1, up 1/2. And we can see that that is flattening out. It's getting closer to the x-axis here. And then we have the point 2, 2. So over 2, up 2. And we can see that that point is a little bit closer to the, actually it's half as close as the parent function. So we have these functions here. That one will continue to go up. Then we have the parent function. That is the original function of the quadratic form. And then we have the a value is equal to 2, and we can see that that is going up quicker than the other